In this lesson, I want to talk about cross-cutting concerns. These are common functions that span layers and tiers. This would include concerns like authentication and authorization. So the difference, do you know that? Authentication is determining who you are, and authorization is determining what you're allowed to do within the software system. It would also include things like caching, which is basically just keeping some data around in memory because it's used so frequently, instead of having to always retrieve it from the underlying file or database. So you can really improve performance by caching at various levels in your architecture. Cross-cutting concerns could include logging features. So if something exceptional happens in the application, what happened? How did it happen? When did it happen? And then writing all that information to a log file that can be analyzed by technical support or the developers. And that's akin to the notion of instrumentation. And it comes in a couple of different forms, but you can think of an audit trail. Who's doing what and when are they doing it? And this could be used to keep track of monitoring who's doing what in the application because there's some legal requirement to do so, or just to see how often certain features of an application are being used and how they're being utilized. Okay, so that's also known as telemetry. Microsoft does that within their applications to see how often features are being used and which ones are being ignored, and that helps them make design decisions in the future. But back to cross-cutting concerns. It also includes things like exception management. So how you handle or throw exceptions between layers. When an exception happens in one layer, do you let it bubble up to another layer, or do you try to handle it in that layer? So how are you going to report critical exceptions to support staff so that they can be proactive in solving the issue, like a website that goes down? What if nobody reports it for an hour? Don't you want to know when that happens? So some sort of exception management and alerting that something's wrong with the application. And then also could include, but not limited to, things like validation. So ensuring that data is valid. That can mean anything from checking the data types, the ranges of values to make sure they're logical, whether data is already in the database and should I be saving it again or updating it, whatever the case might be. All right, so ideally the functionality for cross-cutting concerns should be centralized in code wherever possible, even though they touch many different layers in the code. If code that generates log entries and writes to application logs is scattered throughout all your layers and tiers, and the requirements related to these concerns change at some future point in time, then you have to update the code throughout the entire system. These are the kinds of things that we've been trying to prevent all along in our discussion about managing change and mitigating change by separating what's similar and encapsulating it into its own layer or component or wherever the case might be. So in some cases, you simply have to decide how you're going to approach these concerns inside of each layer. So for example, with validation or exception management, you just need to decide how you're going to handle exceptions inside of the layer boundaries and when you decide to report them to another layer. The same is true with validation. You'll want to do some validation of the data at each layer, but the types of validation will be different because of the nature and the role of the layer, of that layer where the validation is happening and where it fits in the overall architecture. In many cases, you'll be able to leverage a library of code, either some API in the .NET framework for these sorts of things, or you'll rely on some third-party open source API. I suppose you could also roll your own if you had some unique needs, but I would see what the .NET community has available and what they've made accessible through open source before I made that decision to create my own. But the main idea that I want to drive forward in this lesson is that you should seek to both encapsulate the specific API that you choose behind a series of general methods. So that's number one. For example, I might choose to use ASP.NET's membership API for authentication and authorization throughout my application. I might ask myself, is it wise to embed calls to the ASP.NET membership API inside of the code base? Is it possible that this would limit me somehow in the future? What if I didn't want to use ASP.NET in the future? Instead, I want to create desktop applications, or I want to use the domain layer and expose its functionality through a web service layer. How would that impact my choice? So I can't answer those questions now. I need to go off myself and think about the implications of this based on what I know about the actual requirements of the application, do a little testing myself, maybe create a little architectural spike like we'll learn about in the next lesson. But if I decided that it is indeed possible that I might need a different method of authentication and authorization in the future, I might decide to do one of two things, and this shouldn't be foreign to you at this point. At the very least, I should be able to create a wrapper or around the API that has generalized methods in it that my application will actually interface or call into. So when I use this term wrapper, I'm suggesting that you create a class with methods, and each of those methods then in turn call methods on the desired API. It should be generalized enough so that you could replace that API under the hood and you perhaps use a different one at some future point in time, but you wouldn't have to change anything about the wrapper itself. You wouldn't change the methods, its input parameters, and so on. So it won't affect any of the code that utilizes that wrapper. And so just so you know, what I just described there is a design pattern called facade, where you create a facade, a thin, pretty layer over the top of some other functionality so that you hide its implementation. Then you can replace that implementation at some future point in time. So that's one way I could handle this scenario. But the second way, I might consider going a step further and use dependency injection to inject an implementation of some cross-cutting concern into my classes. So for logging, it would be easy for me to create an iLog interface. It would be easy for me to then define some basic methods in that iLog interface and then implement the iLog interface in a class that then uses my desired API or open source library. Now, if I need logging in the future, if I need a different type of logging in the future, I can merely create a new implementation of that interface, of my iLog interface, and then create a new instance of it in my application at startup in the composition root, if you will, like we learned about in the previous lesson. And nothing else about my application would need to change. So those are my options in that regard. So how do you find a library, whether it be open source or something in the .NET framework, that will address your cross-cutting concerns? Well, one place to look, again, I'll point you to Microsoft's Application Architecture Guideline, which in Chapter 17, it lists several popular libraries for each of the types of concerns you might come across. There's always a possibility, however, that some new library has entered the scene, and the .NET community may have shifted towards that new library or solution because it has some favorable feature to it. So there's no silver bullet here. You need to do some research. This means you need to do some clever keyword searches, use the names of existing libraries with the keyword versus or just VS, and then let the search engine give you some blog titles that could point you in the right direction. And also, if you've ever visited the website Stack Overflow, it's another great resource for developer input. I've been relying on it to increasingly for this sort of thing, just to bounce ideas off of other developers or see that, hey, other people have had the same challenge, and these are the libraries that they've used to address those cross-cutting concerns. The chances are somebody has already asked the question or for the kind of input that you're looking for there. When selecting an open source library to support a cross-cutting concern, I'd recommend two things. First of all, keep an open mind. You probably will want to replace this in the future, so don't design the facade that will sit over this or the wrapper that'll sit over this API or this library. Don't design it so tightly that it mirrors this particular API for the library that you select. Make your facade as generalized as possible. I dare even say that it should be chunky and should express a generalized task, even if the library that you choose is so flexible that it requires a lot of setup to use or requires multiple methods to be called. Hide all that complexity and make it logical how you would expect to call a component that will do logging, for example, all right? And then worry about the implementation details, what happens behind the scenes. Try to encapsulate all that behind it. And then the second thing I'd recommend is that you look for a library that seems to be popular and has a lot of support and interest. So these tend to have a longer shelf life. I'm not the first person to jump on a bandwagon, a technology bandwagon, and for good reason. I've jumped on the wrong bandwagon before, many times. So now I tend to choose a safer pick that has lots of support, lots of questions and answers. I see lots of questions about it on Stack Overflow, or there may even be videos or YouTube videos that help me understand more about it. I choose that one over something that's new and exciting and experimental. I might still keep my eye on that one because I may want to use it in the future, but I don't want to be the first person when I have a deliverable to find a bug in some library or choose a library that has no documentation other than a few blog posts. All right, so that's really all I have to say about cross-cutting concerns. Again, the Microsoft Application Architecture here guide can be your friend. It talks a little bit more about cross-cutting concerns. You'll probably know what those are. They'll be dictated to you to some extent by the stakeholders within your organization, people who say, hey, we need to log this, we need to report that, we need to handle authentication. And so these things will kind of drive themselves and dig themselves into your architecture. It's just up to you to make sure that you don't implement them in such a way that it's impossible to change out the underlying implementation at some future point in time should you find a better library or a different way to actually take care of that need, that concern within the application. All right, so in the next lesson we're going to talk about driving an architectural spike, and we'll begin the process of wrapping up this series. We'll see you there. Thank you.